Guys, you had your exams returned to you. I sent those solutions out. And like I said, though, I saw some good things being done. I can sense, with all the experience I have, when a square of paper, I can either realize that yes, my students are studying, they're putting some study time in, or no, they're not. And at first, some students were not putting the time in. This test showed me they are. They're putting the time in. Okay, so which I appreciate, and I hope that continues. Now what I need to do is part one. We're closing down chapter 4, and let's hope chapter 4 gets closed down tonight. I have not yet, myself, done this at all. My goodness, here we go. And before I tell you all about this exponential function in chapter 4, let me remind you that word function is attached to, and I know I've said this many times, probably the first day I met you guys, I probably mentioned quadratic and I put function on it, quadratic function, linear function, cubic function, square root function. Everything's a function. Polynomial function, rational function. Now we have a new one called an exponential function. So this course should be just renamed functions. That's what all it's about. Guys, these should, since they're going to be a function, they should pass the vertical line test, and these will pass the vertical line test. Now what do they look like? Well, your textbook, and I think on the handout, I hope, did I give a definition of what an exponential looks like on the handout? Did I have exponential there on one side of that handout or not? Okay, did I have like f of x equals something? Did I put a capital C? Okay, so your textbook does this, guys. This is the definition. F of x is equal to, that's better. Michael, these markers are going out on this. Okay. F of x, that's better, is equal to capital C a raised to the x. Is that the way it looks on your handout? Yes. So if a function looks like that, it's known as an exponential function. I hope on that handout I point out some restrictions here. Did I point out that this a must be greater than 0, but don't let it be 1? Is that true? And by the way, when I use the word exponential, I'm sure we all recognize inside there is the word exponent. We're talking about something raised to an exponent on an exponential function. Restriction, that base, a is greater than 0, don't let a be 1. The reason they do not want a to be a 1, you're raising 1 to a power, 1 raised to the x, that just gives you 1 for an answer, it's too trivial. Don't let a be 1. And did I mention the c here? Did I mention anything about c? Was it any real number? Cannot be 0. C cannot be 0. Out here. Is that the way it's written on the handout? Okay. So guys, if it looks like that, it's an exponential function, and you know, every time we mention function, we have to graph it. I'd like to see what this function looks like as a sketch. But first, number 2, an example. F of x is equal to 2 raised to the x. That's an exponential function. My base A in this case is 2, which is greater than 0, satisfies the condition. It's not 1. And I have understood out front, if you wish to write it, understood to be a 1 for my C. Now, before I start sketching, in fact, let me sketch now. I'd like to see what 2 raised to the x looks like and what an exponential function looks like. Right now, why not? There's 2 raised to the x. Guys, I'm going to approach this through a table of values. And you can create values of your own. I'll use for my values a little mixture of numbers here. It's got x, 2 raised to the x. And we'll try those replacements. Let's do those in at random. 2 raised to the negative 2. I'll come back to it. 2 raised to a negative 1, just creating points. 2 raised to the 0. 2 raised to the 1. 2 squared. And guys, 2 raised to the negative 2, I hope you all recognize as the same as 1/4. 2 raised to a negative 1, I hope we recognize that's merely 1/2. 2 raised to the 0, everyone recognizes. Anything raised to the 0 power is 1. The last two are givens, 2 and 4. They're easily done. So I create some points. Now if I plot those points, I'd like to know, what does that sketch look like? Is it a parabola? No, it says 2 raised to the x, not x squared. Straight line? No. So guys, let's see what this example of an exponential looks like as a graph. I'm trying to find a marker to work for me. Okay, let me mark my axis to get ready for it. -1, -2, got 0 here, 1, 2. So guys, from my table, we got -2 paired up with 1/4. So it's barely above the x-axis. If I plot the point, -2 up 1/4. Somewhere right in there. -1 goes a little bit higher, goes up to 1/2. 0 goes up to 1. I'm going to mark by 1 as a reference. 0 goes up to 1 from my table here. 1 up 2, I think it was it guys? 2 raised to 0? Yeah, 1, 2, out 1, up 2. 2 right here. Plot that, and I'm just taking those points from that table and plotted points. Are we okay? Is that reasonable? Now if I connect, let's see what this shape may look like. If I have all my numbers correct, 1/4, 1/2, 1, 2, and the last one of course goes up to 4. If you want to put 4 on there, go for it. It's up here. And that was out 2, up 4, somewhere in here. Connected? Well, something like this. That's your shape of an exponential function. Not a parabola, not a straight line, it's a curve that looks something like that. Now, one thing I want you to take notice of on that graph, I think this is one of the few functions that looks like, look how fast it takes off, like this. I'll give you an example of something in real life where you see what this means. Guys, it really takes off out there quickly. Is there a horizontal asymptote involved here? What do you think is serving as a horizontal asymptote, if anything, on this graph? The x-axis. So I'm going to test the x-axis. Y-intercept 1, and then it takes off right quickly. Now that's 2 raised to the x. Since I graphed that, let me do this. The domain on this graph from left to right, no problem. It's all real numbers. The range, the y values, the up and down, yeah, it's dropping down close to 0, which is the x-axis. We'll never get there, and rises forever. So there's my domain and range on my first exponential function. Basic graph. Now I'd like to graph number 3 here. Another graph on that grid. I guess we'll try this. G of x is equal to 2 raised to a negative x. And see, what effect does that negative sign do to my so-called parent graph in the orange there? Any suggestions on how to graph 2 raised to the negative x? I've got 2 raised to the x. What effect do you think that negative sign is going to have on this? Oh, tell me again. Reflect through the y-axis? Is that what you're telling me? Okay, he says, Professor, I think if you just take that orange graph and reflect it through the y-axis, you have 2 raised to a negative x. Now I'm going to verify it, confirm it. He's going to do this. We'll see why. Are you telling me the graph might look like this? Or 2 raised to a negative x. Is that what you have in mind? Okay, so this is y is equal to 2 raised to the negative x. And of course my orange graph is my so-called parent graph. That was 2 raised to the x. You think that negative sign, that's the effect it has. It has a reflection through the, like a transformation, a reflection through the y-axis. Now we'll confirm it though. Can anyone tell me another way to rewrite first? 2 raised to the negative x can be expressed as, give me another version of 2 raised to the negative x.
1 over 2x.
Okay, can we get?
1 over 2x.
Okay, I prefer this. I know what you're saying though. 1 over 2 raised to the x. You could rewrite 2 raised to a negative x as 1/2, like a reciprocal. That's all that negative sign says to do, form a reciprocal raised to the x. I'd like to confirm what was just given to me as that blue graph. I'd like to confirm that. And guys, let's do another table on the side here. Now we'll do it with 1/2 raised to the x. That's 2 raised to the negative x. Numbers, we'll start the same numbers. -2, -1, 0, 1, 2. Then I try it back here. And this one is for 1/2 raised to the x in my table. You guys will end up with 1/2 raised to a -2. I'll come back to it. 1/2 raised to a -1 with the help of the table. 1/2 raised to the 0, no problem. 1/2 raised to the first, no problem. 1/2 squared, no problem. That's what it says to do. Now, if I go back and actually find those values, guys, who has an idea? What is 1/2 raised to a -2 going to give me for a value? Anyone have an idea? 1/2 raised to a -2. What's it equal to? 4. It is 4. Guys, all that negative sign says to do is to find the reciprocal of that base. So if I find the reciprocal of 1/2, flip it over, I get 2 and squared. Same thing down here, 1/2 raised to a -1, take a reciprocal, you end up with what, 2? Anything raised to the 0 is 1. Of course, this is 1/2, and this is 1/4. Now, I like to plot those points. If I plot those points, I think it's going to come out to be that blue graph, just to confirm. Guys, it says -2 up 4. Oh my goodness, stop me labeling things here. -2 up 4, does it make sense it may be up here? -2 up 4 from the table. -1 up 2, here's my -1, yes, maybe this is up 2. 0 up 1, definitely is confirmed. Out 1 up, looks like 1/2, makes some sense, looks like up to 1/2. And 2 is only up to like 1/4. I think the blue graph is there, if you plot points. So it's a reflection through the, as given to me, through the y-axis. No problem. Okay, so reflect through the y-axis. Now we'll try one more item here, number 4. And by the way, guys, I couldn't list the domain and the range on the blue graph, but I think it's obvious. It's the domain and the range on the blue graph, the same as the domain and the range on the orange one. Same thing there. Next one looks like this. Let's try this. H of x is equal to, suppose the negative sign is out front. Now, what effect do you think the negative sign out front means from information we have from previous classes? Do I need to form a table again and plot points? I could. That's a little time consuming. Guys, what do you think that negative sign stuck out front may give me in terms of a graph without going through a table? Any ideas?
Reflection across the x-axis.
Okay, reflection through, if the negative sign stuck out front, a reflection through the x-axis. Okay, here we go. Reflect through the x-axis. So without a table, guys, let's go back to my parent graph, the orange graph, reflect it, and if I reflect it through the x-axis, and be careful here, this would be -1, does it look something like this? If I reflect the orange through the x-axis for a rough shape. Is that true? Okay, Okay, so this represents y is equal to a negative sign out front, 2 raised to the x. So basically, that's what's going on. They're going to give you an exponential function, maybe ask you to do a transformation on it, and graph it. Now, I brought in, it may not be on your handout, but check and see if I still have it. I do. I like to sketch this before I move any further. One more function here to sketch. Guys, number 3, number 4, number 5. I'd like to, if I can, number 5. Let's sketch one more, and it looks like this. It's an exponential function, but it's a busy one. And it looks like this. Negative out front, 2 raised to 3 subtract x plus 4. I'd like to, hopefully, through transformations, not a table, sketch that. Now, here goes. This is my last sketch here. Let's go through the transformations. Guys, and try the red marker. Remind me again, what might this indicate to do? The negative sign stuck out front. As a transformation. Reflect through the x-axis. So I'll do that in red. Reflect through the x-axis. Now we'll pick up my orange marker. Now tell me, I see a 3 minus x coming up next. So can someone be clever and tell me, you've witnessed this before, what might you want to do with that 3 minus x? And you've seen this happen before in some previous problems.
With the negative x plus 3.
Thank you, Isabel, is that you?
Yeah.
She says, Professor, go ahead and first get that x for the first term. Rearrange it as negative x plus 3. Then, what else?
Factor out the negative.
Oh, wow. Factor out negative. And make it look like that. Negative sign stuck out front, x minus 3. Now, with that form, let's identify additional transformations that have to be done here on this last graph here. Now, guys, we're doing an orange here. The negative sign that we picked up with Isabella's help, what does that tell me to do eventually? Reflect through the y-axis. We saw one earlier. So this is a reflection through the y-axis. Guys, I'm marking this thing all up here. The x subtract 3, let's hope one of these red markers will help me. X subtract 3 may tell me to do what? I don't want to do it red, it's something else with red. But what would that x subtract 3, guys, more than likely tell me to do as a transformation? Thank you. That's where horizontal shift, trying to find a movement that works. Horizontal shift to the right, 3. We've done these transformations before. A horizontal shift to the right. Three units. And then all of a sudden, we got a plus 4 hanging on it. That plus 4 tells me now what else should be done. I think, what was it back then? A vertical shift? Was it a vertical shift? Upward? Try to do that in green. Let's see if this will hold up for me. Plus 4. Ah, beautiful. Vertical shift. Up. 4. Wow. I got the red, that orange, the blue, the green for a final graph in terms of transformations. Now in your parent graph, what is your professor? You're doing 2 raised to the x. That's your parent graph back here. We'll first sketch that 2 raised to the x first. You guys can see what that looks like. And let's try to put all this together. Now when I finish it up, let's see what does happen here. raised to the x. That, maybe do it like this. Guys, I'm gonna put the parent graph in black here. Its shape, of course, is this. There's my parent graph. Y to the 2 raised to the x. Now, the red one. We flex that through the x-axis. I gotta be careful myself with all these colors going on here. Reflect that black graph through the x-axis, I'm down here at -1. And the graph may look something like this. You guys, please keep track of all of this. So there's the black reflected across the x-axis. Let me label so I will not forget myself. This is y is equal to a negative sign out front, 2 raised to the x. Now, I think we did the orange. I hope we did. We did up here. Now reflect that through the y-axis. You guys, help me out here. Reflect the red graph through the y-axis, please. Is it going to look something like this? Let me step back and look at it. Is that close enough? Reflecting through the y-axis. If so, I'll label this as y is equal to negative sign out front, 2 raised to negative x. Yes or no? So far so good? Okay. Now the next I think I did in blue, it says now please do the best you can, horizontally shift that graph 3 to the right. Now guys, this might be tough. 3 to the right. I'm going to mark to show 3 units. Okay, so we're looking at, I think, the orange graph, best I can, being pulled over, horizontally shifted, what, 3 to the right. This point right here, definitely 0 down 1, is now going to be here on the blue, to show a horizontal shift to the right. With that one point, if you don't mind, I'm just making it look something like this. The best I can do to show, I'm trying to show that the blue graph represents that orange one being shifted to the right, which looks like it is being shifted to the right. Woo! One more. Vertically in the green, shift this up. Where's my green marker here? Vertically shift it up 4. I'm going to get ready for 4 here. Guys, we're going to take the blue and vertically shift it up 4. This point right here is what, 3 down 1? At this point, if I shift that up 4, I know where it's going to land. It's going to be what, 3, 3? I shift it up 4, so I know that for sure. That's supposed to be done on the green. Okay, so this is going to be your final graph. So out 3, up 3. Definitely, it's going to be on there. Right here. That's 3 up 3. That's on that for sure. Oh boy. This is blue. So I know it's going to be doing something like this for my final graph. Should resemble the blue, but being vertically shifted up. What do you think I'll be asking? And let's hope I'm looking at my function. Let's hope. Oh, here it is. What do you think I'll be asking for you to show me on the final graph that I've asked in the past, before you actually draw the final graph? Who recalls? When we had a quiz or an exam on transformations. There you go.
X and Y.
Thank you. I'd like to know where will that final graph cross the x-axis, if it does, and where will it cross the y-axis? Isabella, thank you so much. So guys, I need the x-intercept on this green graph. Finish it up. Now I need to know, if I can, where's the y-intercept? We'll plot those, connect, we'll have the green graph. Guys, to find the x-intercept, the process always is to set the function equal to 0. That means I gotta go back and make it look like this. 0 is equal to, and my function was really strange, looks like this. Ah, beautiful. Now I'm supposed to solve for x. How am I gonna solve this thing for x? First, I'm gonna move the 4 over to the other side, make it -4. Watch carefully. Does anyone have an idea what might be wise to do next? I move the 4 over, I'm attempting to solve for x, get x by itself. What might be wise to do next? You're sitting there trying to solve for x. What are you gonna do? Next step. Oh boy. At this point, what we do to try to solve this? I'm gonna get rid of those negative signs. I'm going to divide both sides by a -1 or multiply both sides by a -1. Those negative signs bother me. I'm going to quickly rewrite it like this. Is that true, guys? Got rid of the negative signs, thank goodness. Now, can someone be clever and tell me, and I know what common answer I've received in the past is, what might you suggest I do next? And it's tempting to do something. I just want to know whether I'm here that this if I say that. What do you think can be done next? What's so tempting to say at this point right here? What do you think the next step might be to try to get x, solve for x? The next step might be what? Okay, here we go. Yes. Go for it.
Make the 4 into 2 to the power of 2.
Now, he's saying, Professor, don't divide both sides by 2. I've had some students up to say divide both sides by 2. I can't do that here. With this, that was just given to me, Professor, rewrite 4 as 2 squared, which it is. And you still have this on the right-hand side. Guys, if with that help there, if that's true, I've got the same base on each side. Common sense tells me if I have the same base on each side, these exponents must be equal. So that really tells me this, that 2 is equal to 3 minus x, and guys will solve for x fairly quickly. I think x, after all that work, are you kidding, x is 1? Is it? So now I know where the x-intercept is, now this is on the green. Ah, it's here at 1. And I have no mistake, let's hope I don't. The y-intercept, that was the x. I'm gonna erase this so you're not confused with that. Well, I just finished up. Here we go. Let's put the y-intercept on the other side. All this was x-intercept. Okay, y-intercept. We know the routine. Find, in this case, f of 0. Place x by 0 back in the original. And I think it's going to look like this. And that leaves me this to worry about. The negative sign 2 cubed plus 4. Is that true? Now what? Trying to find where does this graph intersect the y-axis. 2 cubed is what, 8? Negative sign stuck out front, -8 plus 4. Guys, if there's no mistake, and check and see if I'm okay there, does it look like that? Y-intercept is 0, -4. I like these written as ordered pairs. So 0 down 4, you go down 4, 2, 3, 4. It's somewhere in there. Let me get out of your way here so you can see what's going on here. We have, in terms of the green points, something like that going on. Is that true? Okay, connected, oh boy. I think, was my last graph, before I did this, the blue graph, I think, was the last graph. If I connect these, are we talking about something that does, wow. Can it do something like this? Looks like a little curve to it. Now guys, look at the blue. By the way, even the way I stretch this out, does it look like I'm intending for that blue to be vertically shifted up? The way it came out for the green? Okay, and has a y-intercept at 4. Wow. Now, are we going to accept that? Will we accept that as a rough sketch of right here? Now, who on earth would think all this business, you're ready to do a calculus procedure on this in math 7, and they're not going to have the time, that professor's not going to have the time, for you to sit there and say, Ramsey shows step by step each transformation to see what that graph looks like. They're going to say, no, go ahead and do the calculus on that. You may not see the graph, but they're going to show you a calculus technique on this. Guys, if that is the graph, the domain on the green graph, what do you think is implied for the domain from left to right? Is it all real numbers? Is that the implication? And the range? What's the up and down? What's the implication there for the up and down, the y values on that green graph? Looks like it's the same thing. Is that true? If all the transformations have been done correctly. Wow. Now that it basically is what an exponential function will do for us. Are we okay? Go.
I think I have a different paper,
That's, I may not be there yet.
but I didn't see the.
No, some of this I'm taking from my notes.
Okay.
I picked from my notes some of this. Okay, by the way, guys, I don't think this one right here was on your handout, was it? I brought this in with my notes here. I don't think it was. Was this one on there? No, okay, it's not on there. No. I took some of these from the notes. Okay. Are there some sketches to be done though on your handout? Yeah, and I'm just doing some from the notes, so you should be able to follow me through this. Okay, Michael, since you're close by, that's done. I should point this out, guys. Jeez. I did business from my notes. I think one of the numbers is I'm gonna point out. Mr. Park, I need your help.
Yeah.
On these exponential functions, Anna and Park will tell you by the time you reach calculus, the calc instructors, for a reason, and they'll let you know what that reason is, they love a special base here to work with. I use the 2 here. You could use the 3. You could use a 1/2 raised to the x. But there's a special number they love to use for a reason, and it's identified as E, and they're going to start graphing E raised to the x. Now, what on earth, Professor, is E? So when I reach a calc class, we're going to have exponentials, but the base may not be base 2, it may not be base 1/2, it's a base letter E. So I'm going to first show you what that means. Now first, though, before I erase some of this, does this make sense? Exponential function, a few transformations on it, domain, range, so forth and so on. Now, Michael, did I mention E somewhere on the handout?
Yes.
Okay, so I missed it. Okay, hang on. Let's do this. You guys, this is going to be a special exponential function. I'm going to erase this. I'll point something else out about this. Okay, part 2. And now I'll take a closer look at some of those items on your handout. Part 2, special exponential function. the way their copier handed that to me, oh boy.
Yeah,
Anna?
I have a different one too.
You got a different one? These guys. We have plenty of papers here. Okay, you want to let me know, let me come by. Anna, help me out. Go through those students who have. I don't think. Guys, there's one set that starts out with 4.5 and then 4.6 on the back. Did you guys get that one?
Yeah.
Okay. Oh, so you did not get the 4.2.
I just got 4.2.
Yeah, that's.
Oh, gotcha, okay, that's what it was. That's the way it was given to me this morning. Here we go. They need the 4.2. Okay, guys, it's all on the same page here. Sorry about that. Sorry. So you guys, you got the 4.5?
No, not me.
I got 4.5.
I have 4.5.
Oh, you got 4.5, so if you got 4.5, raise your hand up, she's gonna give you the 4.2. And then I'll give the other students who need it a 4.5. I'll get this straightened out. Who needs a 4.5?
You guys okay?
That's what it was. 4.5?
Two.
Oh, you need two. You need 4.5?
Five?
Oh, yeah, I got
This is 4.2.
Wait,
Whoa, is it?
hold on. 4.2, because this is 4.5. This is 4.2.
Okay, now who needs 4.2? There's another 4.2 if you need it.
Yes.
Sorry about this, guys, it's good to see you this morning. Now, 4.5. Who needs 4.5?
4.2.
5, 4.2.
4.5?
4.5.
Do you need 4.5? 4.5?
Okay, so hands going up. Isabella, which one you need?
4.5.
Gotcha. Hey, some of you guys gave me strange looks when I was doing this on work. Oh, where is he? 4.5. Jonathan, which one you need? You get 4.5? Okay, guys, make sure we have both handouts in. Jeez. Okay, Mark's gonna help me out here, guys. I'm gonna take a close look at some of these examples, sure. I need to establish a special exponential function. Here goes. I'm gonna construct a table, place some numbers in the table, show you what's gonna happen here, and establish some of us may have seen, but maybe did not realize where it came from. You guys will have an X column, and then my second column is gonna be something really crazy. It's gonna look like this. One plus one over X, raise your hand.
The graph, the green one, so the range is negative infinity to infinity?
It was. On which one now? We
For
looking at?
the green,
Oh, the range?
yeah.
Yeah, right here?
'Cause I thought it was the range, I thought it ended like at 4, I think, from negative infinity to 4. And then I searched up on Desmond, it looks like the range is different.
When you graph it there. Maybe it's the, window that you're using, maybe it's not large enough. Guys, was it negative infinity through positive infinity here? I left this one. Is it? I think it was, wasn't it? The range on this? I think it was maybe that window you're using. There. I'll take a look at it though. Guys, 1 plus 1 over x raised to the x. Mr. Park, you've gone through this with me before. I'm gonna place some numbers here, guys. Now look what I'm replacing. And I'll get out of your way here. And I can place more. Some large numbers in that x column. Thank goodness he's here. He's gonna help me because I need to go over on this side and replace the x's by those replacements. So guys, on the left-hand side, I've got some large numbers. Can someone in this clever class tell me what conclusion could you write just about the left column? I've got 10, 100, 1,000, 10,000, 100,000. I may ask him to even do 1,000,000 here shortly. Some large numbers. What might you tell me as a good, clever student? What am I trying to illustrate is going on for the x? With those large replacements. What am I saying about the x itself with these large numbers? Have we got a clever way to illustrate that? I've got a little graph up here, or a little table, but what does that really say? I start with 10, went to 100, went to 1,000, 10,000, 100,000, 1,000,000. How might you express that in math? What is x doing? X is doing this. X is the first infinity. I just place some numbers. So x is getting really large. That's what I want in that left-hand column. Now I want to know what effect do those large numbers have on this strange expression that I just gave to you. I didn't show you where it came from. But Parks will help me out. He's got to do this. 1 plus 1 over 10 raised to the 10th. I'll come back to it. 1 plus 1 over 100 raised to the 100. 1 plus 1 over 1,000 raised to 1,000. 1 plus 1 over 10,000, this is getting crazy, raised to the 10,000. And the last one, right now at this point, is 1 plus 1 over 100,000 raised to 100,000. Now, can you imagine if I asked you as a student to calculate what those values are in the blue? That would be madness. Now he's going to do it for me. Mr. Park.
Yeah.
Can you do the first one? 1 plus 1/10, you call that 1.1 if you wish. Raised to the 10th, what is that close to?
2.594.
5, 9, give me 3 digits.
594.
594, okay. How about 1 plus 1 over 100, raised to the 100. And you may want to put that in there as 1.01 raised to 100. What's that close to?
2.705.
705. How about the next one where it says 1 plus 1 over 1,000 raised to 1,000?
2.717.
717?
7. Yeah.
Now we're getting larger. 1 plus 1 over 10,000 raised to the 10,000.
2.718.
8. Now the next one's larger. 1 plus 1 over 100,000 raised to 100,000.
2.718.
Tell me again?
2.718.
Wait. Are you tired? You made a mistake?
No.
Gee. You see, I mean, you got close to 2.718 again. Park.
Mm-hmm.
Let's put in 1 million.
1 million.
Hang on, before you do it, I'm adding to the table this, and he's going to do this for us, because he's here. 1 plus 1 over 1 million, can you imagine doing this? Raised to 1 million. Mark, what's that close to?
2.718.
8 again. Now, by the way, I asked him for the 3 digits, 3 decimal digits, and he said 718. Mark, when you looked at those 718, 718, and 718 that came out, was the 4th digit a little different?
Yeah.
Yeah, the 4th digit differed a little bit, but to 3 decimal places, it's 2.718. 2.718. Now, based on this table, and with his help, let's write the conclusion, guys. The conclusion is, here goes, the limit. As I made x get large, that's what that part of the table in the green, that's what I'm illustrating, getting large numbers. As you make x get large, my strange expression, 1 plus 1 over x raised to the x, is getting close to what? Roughly what? 2.718. Is that true? Now they identify that special number for us throughout all the math courses as, we're going to call that number E. Its approximation is, to 3 decimal places, 2.718. But that's the conclusion from the tables. Left-hand side, you're approaching infinity, large numbers. I asked him to put large numbers into that strange expression. We did. He says, Ramsey, the larger it gets, the closer you get to 2.718. So it's like a limit. And they identify that with E. Now, why I bring this up? Because a lot of the calculus is based on this special number here. Guys, I'll accept E as roughly 2.718. But right here, the reason we're doing it is, for an exponential, they are going to say, now consider f of x to be equal to E raised to the x. I saw 2 raised to the x earlier. 1/2 raised to the x earlier. Now how about this strange number E raised to the x? Guys, I'm not going to plot points like I did for the others. I'm not going to form a table. Does anyone have an idea of what could I do to get a rough sketch of what on earth does E raised to the x look like? I saw what this looked like. I saw the others that I erased over here, what they look like for an exponential function. So this one has to take the same type of shape. What do you think I could do to show on a grid a rough sketch of the graph of E raised to the x? Any ideas? So you'll be ready for math 7 when that instructor says we're going to look at E to the x. You'll say, oh, that's just an exponential function with base E, where base E was roughly 2.718. What do you think, guys? What does it look like as a graph? It's an exponential. Oh, by the way, the restriction here, I erased my restrictions. Was the restriction right here? Who was it? I mean, for the A. Was A supposed to be greater than 0? I don't want the A be 1 for the base. That fits my description. E is roughly 2.718. So it is an exponential function. It's a special exponential function. What does it look like as a graph? I'm going to graph real quickly. Yeah, I guess for the first graph, again, place 1 here. I'm going to have this to represent, again, 2 raised to the x. I graphed that earlier. We saw what it looks like. That's 2 raised to the x. Can anyone tell me, without going through a table, which we could, does anyone have an idea of what 3 raised to the x might look like? That's 2 raised to the x. Does anyone have an idea, without going through a table, what 3 raised to the x may look like? Or we could construct a table and plot points and find it. What do you think 3 raised to the x may look like? I said 2 raised to the x. Any ideas? Without going through a table? What 3 raised to the x may look like? Let me show you what it's going to look like, because I need it. It's going to be closer to the x-axis. I'll evaluate here, guys. Still going to go through 1. And a little steeper there. I'm going to let that represent y is equal to 3 raised to the x. And you could plot points. Now, where e raised to the x, which is 2.718. Where's it? It's caught between those two. It's caught between 2 and 3. So if you say without going through a table, Professor, and you want just a rough sketch, guys, notice all these sketches are looking so much alike. If I squeeze in the best I can between these two graphs and have, really squeeze in, I'll get out of your way here. Squeeze in and come out, still go through one, and fall between the red and the green graph. It's going to look something like that. The blue one, I'm going to let the blue one represent a rough sketch of e raised to the x. It's caught between 2 raised to the x and 3 raised to the x. It's squeezed in between. Now, what's calc instructor will allow you to do? I would allow you to do this. If I say sketch for some reason, you're going to do some work with it, e raised to the x, and you say, Professor, my goodness, will you accept this? Y-intercept 1. Will you accept this, Professor, for a rough sketch of e raised to the x? I will. Would you accept, Professor, if I need 2 raised to the x, a rough sketch, would you accept that? I will. 3 raised to the x, I know 3 raised to the x is a little bit steeper, but basically, that's the graph. 4 raised to the x, I'll accept it. The guys will let this be e to the x, 2 raised to the x, 3 raised to the x, 4 raised to the x. Each one's a little bit steeper. But for the purposes of what we're doing here, I'm going to use that as my graph. Guys, how's that look? By the way, let me see by a show of hands, how many students recognize or have seen maybe the letter E? I see 1 hand going up, 2 hands going up. Okay, it's just a special notation like pi is in math. We now have E to represent something. It's roughly 2.718 in an exponential function. Guys, basically that's what's going on here. Now I started to, but watch my time here. I just want to take a break here shortly. I'm trying to get this chapter 4 a lot of done tonight. Let me point this out. Should I do this? Let me leave this thought with you to sort of close down this. On the handout, Michael, since you're close by there, on the exponential functions, can you see anything else on that handout that maybe I have not discussed? Or have I done some examples of everything on there? I may not have worked these same examples, but have we basically done everything that's on there for exponential functions? Or was there something else? I did? Guys, you agree? I guess that's what, 4.2? Oh, yeah. Okay, so guys back here, he's saying about Professor, your basic definition for an exponential function looks like this. I'm glad you brought this up. The base must be greater than 0, don't let it be 1, you know that. X can be anything. C can be any real number. Now, if I ask you to do this, I know exactly why I brought that, point that out. Guys, if I saw this, now here's an example of what Michael says is on the paper. I'm gonna let C in this case be 3. And then my basic function I've been dealing with today, 2 raised to the x. What's tempting, very tempting, for a student to do if it's written like this, which looks like the form I want, but what's so tempting that you really cannot do here? Thank you. Multiply 3 times 2 and call it 6. Can't do it. So tempting. That's where students go wrong. You still got to separate and deal with that separately. Okay, then 3 times that. You cannot multiply 3 times 2 and call it 6, or 6 raised to the x. So guys, with all that said, now, I'm not going to do as much as I thought I would do on this. Sharp, oh my goodness, this thing is rising like crazy. Like crazy. I was going to bring you in an example of, since you guys are online all the time, always looking at videos and this and that, and sending off, you see a nice video, you want to send it off to your friends, and then your friends send that video off to other friends, and all of a sudden it goes viral. Is that true? That's an exponential function. That's how fast it can grow. Okay, so if, let's say, you saw a video of Ramsey doing something crazy, and you want to send it out. Okay, and let's say that, the video has been seen, and all of a sudden it's been sent to Park and Anna. They liked it. Ramsey's trying to do something with Bruno Mars on this video. You gotta see Ramsey's crazy. Okay, then these students send out the video to two others. And then these have two friends, and they send that same video out. And please tell me this routine, is it gonna go viral down here? It's going crazy on us. And pretty soon Ramsey's all over the nation. My goodness. Yeah. I'm an influencer. Gee, right? It's going crazy on us. Now, that's an example of how this thing could really take off. I was going to actually write a formula for this. But it could really take off, guys, and end up with some crazy big number. You know how this is. You could end up with, by the end of the day, if you did this, over, I think I did a calculation, over 8 million. So we have to move mine up here, views of that video. Okay, so that's what an exponential function does. It takes off quickly. Any concerns about that? Just a basic exponential function. And all that. Now, I know it's almost time for a break. To close down chapter 4, I'm going to ask us to do this. Given this exponential function, now we'll close down and we'll take a break here. Find, here we go, guys, its inverse. Now your quiz, one part of the quiz on Wednesday will be to find an inverse, not necessarily of an exponential function. Now before we close down, take a break here, guys, please tell me that there are only 2 steps to find an inverse. Step 1 is to do what? To find the inverse. Only 2 steps. You interchange the x and y. So we'll make this side the x, which f of x is y right now, is equal to 2 raised to the y. That's the first step. Second step to find an inverse, like you will on Wednesday's quiz, you gotta solve for y now. And if you get y solved for, that's the inverse. Anyone tell me how on earth are you gonna get y by itself here? In other words, solve for y. I hear that so often. Tell me again.
Dividing both sides by 2.
I'd say divide both sides by 2, and we can't do it. Now, I know exactly what, Isabella, as a student, I would say the same thing. She's saying, Professor, you're going to get that y by itself, do this. I know exactly what she wants to do. I would as a student also. Cancel these out, Professor. That leaves y. And then you've got that mess over there. X over 2, and that x over 2 is going to act as the inverse. Guys, this right here, though, I cannot cancel the 2 out. Can anyone tell me from algebra 1 or algebra 2, what does this really say right here? Some should be an exponent of 1 down there. What does 1 do with the exponents in a case like this? What should I do with those exponents? And there's a rule there, which we're going to look at later on, that looked like this way back in algebra. In a quotient, what is 1 supposed to do with the exponents? I'll give you a hint. In a product, you add them. What are you supposed to do in a quotient? Subtract them. So this would be base A raised to the m minus n. That's going to come up. Isabella, I would have missed it as a student, but this really says 2 raised to the y minus 1. Darn if they don't cancel. I wish they did. Now, I know it's time for a break. Does anyone have another idea? I would have done exactly what Isabella suggested. It's not going to work. I wish it would. That would be a quick way to find what I need. Guys, I can't do that. Now, if anyone give me another suggestion at this point, what might you do? If someone gives me the correct response, I'm going to be so pleased. What are you gonna do to solve for y? You will get y by itself. And you can't not divide by two.
You said the left side equal to 2 is to the x.
Ooh, I see why, two raised to the x. Can't do that. I'll show you why a little bit later. If anyone can tell me what y is, I will be shocked. I'll be happy. As an instructor, does anyone think they know what y is equal to? You're trying to solve for y. Can't divide by two, looks so tempting. Can't do anything else with it, I heard. Guys, here it goes. I'm just going to show you what it is. That's going to introduce me for the lesson after the break. Y is going to be equal to, look at this, log base 2 x. We're into logarithms. Oh my goodness. Now, after the break, if I can get this section on logarithms covered pretty well, you guys have a good understanding what a logarithm is and why this mess came out like it is. We'll have that chapter 4 basically done. Guys, any quick questions before we take a break? We've got quite much done here. Okay, take a break.